Okay, so in today's video we want to look at classifying the nature of stationary points. So we want to obviously find the stationary points and then determine whether they are local maxima, local minima, or maybe stationary points of inflection. So just to remind you that we'll have a local max at a point if the second derivative is negative. We'll have a local min if the second derivative is positive, and well, of course if the first derivative is 0, and we'll have a stationary point of inflection if the second derivative changes sign. So just to be very explicit, it's the opposite of what you think it would be. You'd expect that second derivative being negative would give you a min, but it's the other way around. As you can see, for example, the second derivative measures the rate of change of the derivative. So here we see that the derivative is actually decreasing. It's getting more and more negative, or closer to 0. So that's something to bear in mind. Okay. So let's have a look at this. First example, f of x is equal to x squared minus 5x plus 6. So we know how to differentiate these. This is just 2x minus 5, and the stationary point is given by solving f prime equal to 0. So this tells us that 2x is 5. So in particular, x is 5 over 2. So that's where the stationary point occurs. We want to determine the nature of it. So we calculate the second derivative. So we differentiate 2x minus 5. That excuse me. That will be 2. And since that is positive everywhere, it tells us that f has a local min at x equals 5 on 2. Okay, let's have a look at sine x. So f prime of x is, and what we'll do actually for simplicity is restrict x between 0 and 2 pi. Then f prime of x is cos x, and if cos x equals 0, then for 0 to 2 pi, well, let's just remind ourselves of the graph of cos x. So cos x looks like this being 2 pi, this being 3 pi on 2, pi being here, and this being pi on 2. So here we have x is pi on 2 and 3 pi on 2. You don't need the graph, obviously, to determine this, but it's just convenient. And so we want to determine the nature of these stationary points. So we note that the second derivative is minus sine x. Now if we put the first stationary point in, f double prime of pi on 2 is minus sine of pi on 2. But sine pi on 2 is 1, so this is minus 1, which is negative, which says we have a local max. And if we have 3 pi on 2, then we'll end up with minus sine of 3 pi on 2. Sine of 3 pi on 2 is minus 1, so we'll have minus of minus 1, which is 1, which is greater than 0, which says we have a local min at 3 pi on 2. And that confirms the graph of sine x, which is natural to expect. Okay, so let's have a look at this cubic example. So here we'll have f prime of x is given by x squared plus 7x minus 8. Now if we set this equal to 0, then what we can do is, well, let's just maybe put this into the quadratic formula. So negative 7 plus or minus the square root of 49 minus 4 times 1 times minus 8 over 2. So what we end up with is 49, 4 eighths, 32. So 49 plus 32 over 2. So minus 7, this will be the square root of 81. So plus or minus 9 over 2, which is 2 over 2, or minus 16 over 2. So that's 1 or minus 8. Of course, you could have just factorized it directly. If we calculate the second derivative to determine the nature, what we'll get is 2x plus 7. Now the second derivative evaluated at 1 is 9. That's greater than 0, which tells us that we have a local min at 1. And if we input minus 8, then we'll have minus 16 plus 7. That's minus 9, which is less than 0. And this says that we have a local max at x equals minus 8. I didn't include any examples of stationary points of inflection here. In future videos I will cover that. I'll also cover non-stationary points of inflection, since that's often a stumbling point for students. And of course, how to put all these techniques together to ensure that you're able to determine the graph of maybe quite complicated functions. Okay, so if you like the video, please hit the like button and consider subscribing if you're new to the channel. And if you have any questions, please leave them in the comment section down below. Thanks, guys.